This are we'll try to use Orange to make sure you understand how to use Orange to perform text-based analysis with language model. Okay, so make sure you have installed add-ons. Okay, text add-on. So right here, I think you should click this one and install these packages, and your Orange will be closed. Okay, and reopen it, and you will have a new widget called text mining right here. Okay, so basically you need a corpus, okay, which is a text-based data, and you need a corpus viewer. Okay, so let's take a look at this corpus. Okay, it is green. I think there's the green tiles. Okay, so we have 44 different articles right here, and here's the content. So that is the text we'd like to analyze, and here we have topic, tales of magic or tales of animal tales. Okay, we have different classes of tales. So first thing, okay, I think we talked about before, but I will show it again. When we analyze those texts, okay, before that we should apply preprocessing. Okay, so here Orange provides some preprocessing module right here, but most of the time we use the default one, which is transformation, okay, to lowercase. As we mentioned before, because when you try to use language model, you need to build your own dictionary at the first place. So to make all the sentence be lower cases is very important. So because it can shrink your dictionary size. Okay, and next one is tokenization. And most time for English sentence we use white space and punctuation to perform tokenization. And that one is stop words. English has a lot of stop words, okay, like the, is, are, but those stop words are not that important from the perspective of text-based analysis. So simply we will move those stop words. Okay, so here we have a word cloud. Okay, so maybe you can take a look at this word cloud. Okay, so in this case it means, but word cloud needs some time. Okay, so in this case when we after we perform preprocess text, okay, so you can see that the and those words are not in this word cloud, and you can see that the highest frequency, the highest frequency of words used is said and can and something like that. Okay, so after that, okay, we can delete this one. After that, okay, we can simply just use a backup words. Okay, we mentioned it before, but let's take a look at it again. You can see that we use a data table right here. So you can see that after backup word, we have an additional feature right here. And as you can see that at the left hand side, we can see that, okay, we have 44 different documents, and you can see that we have 3,719 different features. And those features means how many different words we use in those 44 tales. And you can see that they are in this document, okay, in this very first tale, it used one able, one accord, one actually, okay, one afraid, one times of ago, and 7 times of up, and so on and so forth, so on and so forth. And total there will be 3,719 different words. So in this case, it has that many features, and in those features, those are frequency count. Okay, frequency count of each word, and that is very similar to what we have told you. It's very similar to one-hot encoding, but let's one hot encoding only specify which word has been used and which word has not been used, right? But in this bag of word, it also record how many times this word has been used in this article. So it's very similar. We can still use this one hot encoding fashion feature to perform classification, right? As I mentioned, we have two different classes, right? Animal tail and magic tail. So we can use these 3,700 features to perform, for example, a logistic regression. And as we can see that actually its classification rate and F1 score is quite high. That means indeed animal tails and magic tails, they indeed use different words in those tails. So that's the reason why we can have a very high classification accuracy right here. Okay, but for some other application, it is not always true. So I'd like to introduce the next one. It's called document embedding. And again, you can see we have two different options right here. The first one is multilingual expert. That means because Orange is they use a very nice package called expert. It is a variation of BERT. Okay, it can accept sentences. Okay, and output a high dimensional vector to represent the input sentences. Okay, and when this BERT is trained, they use different language document to perform closed test. Okay, to perform MLM. Okay, so if you're interested in these things, maybe you can simply just use expert and Python. Okay, there's a very nice document, and as you can see that to use expert is very simple. The first one is to import them and use the sentence that is the model. Okay, the model name is O mini LM. Okay, 6 layers, version 2, and you prepare your sentence to encode. So we have 3 different sentences right here, and we simply just feed those sentences into the model for encoding, and the embeddings right here. And you can see that the embedding size is 384. Okay, unlike BERT. The BERT output dimension is 768, but expert its output is 384, right? And since everything is in the latent space, so we can use similarity to compare, to calculate the distance between different sentences. So in these cases, we can see that the first sentence and the second sentence, that is the distance matrix, right? So right here, we can see that the first sentence and the second sentence, they are similar. And we can see that the first sentence is the weather is lovely today, and the second one says it is so sunny outside. Basically, they have quite similar meanings, right? But the third one, he drove to the stadium. That is not even close to these two sentences, right? So it is very simple to use expert, okay? But you cannot fine-tune it in Orange. Orange simply just let you to output those embeddings of your sentence. So very similar to the code. The document embedding simply just output the text-based data to, again, 384 latent space right here, right? So each row right here, okay, each row right here, it is the embedding of this entire content, entire tails, okay, no matter how long it is, okay? So that is how expert works. It can create the embedding of a very long document or sentences. Okay, so after that we can still perform classification, right? So here we still use test and score, and we use the same logistic regression, and you can see that it is even higher than the previous one, because the sentence bird is a transformer. Okay, it has attention structure, so it knows what exactly those sentence means. Rather, the backup word does not know what exactly the sentence means. It simply just count the frequency occurrence of each word as its feature. So if you want to analyze text-based data, you can simply just use SBIRD to transform your text-based data to numeric data, right? The other option is fast test. We told it before, right? Fast test has two different module. The first one is Hsiao, the other is skitgram, and by default it should be skitgram. And of course, fast test also provide different languages, so it depends on of course Chinese is in it and others in that language. Okay, so you can use it, but for skitgram and Hsiao, when it only tell you what exactly a word's embedding is. So if you want to embed a document, you have to aggregate all of your sentences and tokens, and it's very simple. It's simply just average all of the embeddings of each word and sentence. So again, you can see that right here. You can see that Hsiao and skitgram, it outputs dimension is 300. So for example, if we take this one, for example, a certain father had two sons, and the older of two was small, and blah blah blah. They simply just use each token to output the 300 dimension vector and aggregate them together. So it is a little bit like a backup word, but as I mentioned before, right here. Okay, so the classification rate right here is even worse than backup word. So my recommendation is that if you really want to analyze meaningful documents, you can simply just use SBIRD, because it is a transformer. It has attention structures, and it knows what exactly a sentence semantic meanings. But fast test, if you aggregate them by using min, it is quite not that good approach to use an average method, an average aggregator to represent an entire document. Okay, so I recommend you use SBIRD. And after you have those embedding, you can perform a lot of different analysis. For example, there are some unsupervised, right? So we can use the distance and to perform hierarchical clustering. So in this case, we can clearly divide. Okay, the blue one, I think the blue one is animal tails, and the red one is magic tail. You can see that those blue animal tails, they are close to each other because they are very close after SBIRD. Okay, and the red ones close with each other, and you can see that the two dots right, two black dots right here, because that is because those those animal tails, they use magic. Okay, that is one of the analysis you can use. Okay, the other one is this one, and of course you can use PCA to perform dimension reduction, so that you can use the first two I think right here you can use the first PC1 and PC2 first one, PC1 and PC2 as the low dimensional projection, okay, and draw this figure. And we can see that the red dots and blue dots are separate, right? Although, make sure you take a look at this one. Although two components only have 20% of the variance, okay. So we in orange we have another smarter way to observe the high dimensional data, that is MDS. Okay, so that means okay, you have to run it. Okay, that means we use the distance of these dots in high dimensional space, and we use those information to draw those dots in 2 dimension. And if the two data points are close in high dimensional no space, and they will be close again in these 2 dimension space. Okay, so if you're interested, you can check out this algorithm. Okay, and another thing we'd like to talk about is DBScan. We have watch and video that talks about how DBScan works, right? We have core point and non-core points, and some points which is not belong to the cluster. Okay, but there's a problem with DBScan is that you need to set 2 important parameters. The first one is the core point neighbors. So that means how many different core points should nearby, so that you can enter that cluster. And the distance to evaluate what is neighbor, it is the neighborhood distance right here. So but orange does not support DBScan quite well, so we cannot draw the figure. We can only, okay, take a look at this one. We can only know what cluster it is, and if it is a core point or it is a non-core point. Okay, so you have to try different parameters to figure out if this cluster is meaningful or not. So but that is, I think that's annoying, because you have to try again. Okay, so far we don't have the second cluster, so that you have to make the distance even smaller. Yeah. Right here, so that you can see that we have C2, right? And of course you can further use this data to perform MDS, right? And use the shape to see what cluster it is. Okay, or use to see if it is a core point or it is a non-core point. But it is not friendly. It is not that friendly to use DBScan in orange, right? Okay, so I would like to introduce another one. It's called self-organized map. Okay, I think that is a very interesting and important analysis. Okay, when we talk about cluster, okay, so SOM, self-organization map, is the only neural network based cluster algorithm, I think. So here we can see that, okay, we will not explain how it works. We simply just show you how it looks like. Okay, so basically the original 44 document are in a 300 dimensional space, right? So we, in that 300 dimensional space, okay, we put a net in that 300 dimension space. Okay, so we see how many different documents are close to the intersection of the net. the basic idea is like that. So you can draw these figures, okay? So you can, for example, that is the size of your net, okay? That is the size of your net. So you can see that it will try to learn at to rotate, to compress, to manipulate that net to fit the data set. Okay, so if you're interested in this, go to YouTube. There were a lot of explanation of how SOM works. Okay, and you can see that different tails are indeed in different space in the original space, and we the SOM simply just draw it in a two-dimensional way. Okay. Let's use another one, for example, because the tail has only 44. Let's take a look at okay, iris. Okay, and again, okay, we can simply just use SOM. Since it is an unsupervised clustering algorithm, so it does not need any labels. And we can see that different cluster, okay, different iris flowers, okay, they will be in different space in the original 4-dimensional space, and in this 2D net, okay, we can put out different samples in this net. And we can see that there's some in some net, we can see that different classes of flowers are in the same net, okay, because they are close with each other. But as you can see that basically 3 different flowers, they are quite clustered, okay, by SVM. Okay, make sure you know how to use SVM. Okay. So I think that is all I like to talk about. Okay, so again, after you have document embedding, you can do whatever you would like to do, because it is very useful to transform text-based data to numeric data. Okay, we stop right here.